All right, in this video, we're going to look at multiplying polynomials. So we'll start here in the first example and take it from top to bottom. It says your landscaping company has been asked to reseed a rectangular football field with a width of 160 feet and a length of x plus 300 feet. So I'm going to write that here on our picture, that it's telling us that our width is 160 feet and our length is x plus 300 feet. Part A wants us to find an expression for the area of a football field, okay? And we're going to give our answer as a binomial here. All right, so remember, formula for area of a rectangle, length times width. All right, so now let's substitute in what we know. We've got a length and a width here. We've got 160 times that x plus 300. And now from here, just to clean that up, I'm going to take that 160 and distribute it through. So 160 times x, 160 times 300 will give us 48,000. And that'll be your final answer. Okay. All right, so now let's move on down to part B. Part B says, let's find an expression for the area of a football field with a width of x plus 100 and a length of x plus 300. And it says it wants us to give our answer as a quadratic trinomial. All right, so let's see what that means for us, okay? So again, area is still equal to length times width. All right, so let's plug in our pieces here. We've got a length of x plus 300 and a width of x plus 100. And so what that means, what they mean by having a quadratic trinomial, that just means that they want us to multiply this, okay? And we're going to talk more about this method here in just a moment. But in order to multiply two binomials together, we use what's referred to as the FOIL method. And so I'm just going to sort of get your feet wet with it, and I'll take it step by step on the next page, though, for you. But this will just give you a little bit of an introduction to it. All right, so with the FOIL method, and FOIL is just an acronym that tells us how to multiply. It tells us to multiply the first terms of the parentheses, the outside, the inside, and the last terms. So the first terms of our parentheses, we have x times x. That's the first terms of both parentheses. So we multiply those, and x times x gives me x squared. Outside, x times 100, 100x. Inside terms, 300 times x, so 300x. And then the last, 300 times 100, 30,000. So 3 with 4 zeros, so 30,000. Last step I want to do then is combine like terms. So x squared plus, what's that, 400x plus 30,000. And that would be our expression there for the area. Okay. In part C, it says, well, let x equal 60, and it wants us to find the area of the football field. And just so you know, this is the actual area of a football field. So what that means is go into our formula that we just found. Everywhere we see an x, we're going to plug in 60. So I have 60 squared plus 400 times 60 plus 30,000. All right, and so then you can do that in your calculator all at one time. I'll show a little bit of work. So 60 squared, that is 3,600. 1,000 on the next term, and 30,000 on the last term. And then I can add all of that together, and that should land you at 57,600. And then we're talking about area. We hadn't mentioned this in a little while though, but area, if we were talking about feet times feet, then the units on that would be square feet, feet squared. That would be our final answer, okay? All right, down below in example 1, we are looking at multiplying polynomials by monomials. And with that, you really are just simply distributing, okay? So this should be a review. I'm just going to do letter C here with you, let you pause and make sure you can check yourself by by the solution key with A and B. So in letter C, I'm going to take a negative 2a and distribute it to all three terms in that parenthesis. So remember, when you multiply numbers, you multiply them as you normally would. When you're multiplying variables, when you multiply variables, when you multiply, you add your exponents. There we go. So negative 2 times 8, negative 16, imaginary 1 on that a, so a cubed. Next term, negative 2 times negative 6, negative times negative gives me a positive 12. A times a gives me a squared. And that last term, negative 2 times 7, negative 14, tag on that a, final answer. If at that stage there were ever any like terms, you would combine them, okay? Example 2 is also very straightforward from the solution key, so I'll let you try that one on your own. Let's flip it on over then to the next page. All right, so this is where I really want to focus more so again on that multiplying one binomial times another binomial, and really give you a lot of visual representation now for the FOIL method. All right, so binomial, 2-term times another 2-term polynomial. Remember, terms are separated by addition and subtraction signs, excuse me. So there's just one term and there's one term, so that makes it a binomial. One term, that makes it a binomial. All right, so now you're using, like I said, the FOIL method. So FOIL stands for first, outside, inside, last. And it's all multiplication. So when you talk about the first terms, you're talking about the first terms of the parentheses. So 2x is the first term of that parenthesis, and 3x is the first term of that parenthesis. All right. Then when you talk about the outside terms, you're talking about the outside terms, so out of each parenthesis. So 2x is on the outside of this parenthesis, 4 is on the outside of the other parenthesis. Inside terms, so what's on the inside of these parentheses? The 7 would be considered inside, and the 3x would be considered inside. And then you move to the last terms of your parentheses. The 7 and the 4 are the last terms in each of those parentheses, okay? So now if we think about going through and we multiply this using our FOIL method, so 2x times 3x, 2 times 3 gives me 6x squared. Outside, 2x times 4 plus 8x. Inside, 7 times 3x, 21x. Last, 7 times 4, 28. You'll many times when you FOIL, you're going to have like terms. So here, 8x plus 21x can be combined to give me 29x. And that would be our final answer. Okay, I showed even more work down here below, okay? All right, let's come on down to example 3. You're foiling again in this example. I'm going to be foiling a lot in this set of notes, so I'm just going to do C here with you at this time, okay? All right, so again, so 2 terms times another 2 terms, so I'm just foiling, so I'm doing my first term. So 7m times m, multiply, add your exponents, so that would become 7m squared. Outside, so 7m times negative 2n, 7 times negative 2, negative 14mn. Inside, 4n times m, so a positive 4mn. I personally just usually write in alphabetical order, but it doesn't matter. And then last, 4 times negative 2 gives me a negative 8, n times n squared. Lastly, combine like terms, so these mn's in the center can be combined, so 7m squared minus 10mn minus 8n squared. Final answer. Okay. All right, let's talk about some special products. The first one is squaring a binomial. So when you're squaring a binomial, whenever you see this this notation here of x plus 2 squared, what that means is to take x plus 2 and write it times itself, or write it 2 times and then FOIL. Okay, write it twice and FOIL it. If it was raised to the 3rd power, then I'd write it 3 times and multiply it out. Okay, so that's all that I've done here is x plus 2 squared means to write it twice, and then I'm going to FOIL it. All right, so coming on down then to example 4, let's look at B and D here together. Okay, so in letter B, 3x minus 7 squared, so remember that means 3x minus 7 times 3x minus 7. And now I just FOIL. So I do my first. So 3x times 3x, 9x squared. Outside, 3x times negative 7, minus 21x. Inside, negative 7 times 3, minus 21x. Last, negative 7 times negative 7, positive 49. Then combine like terms in the center. So final answer then, 9x squared minus 42x plus 49. Final answer. Okay. I wanted to do D with you as well. I didn't want the fraction to scare you off. You've got a term or a binomial here that's being raised to the second power. So that means I need to write it twice so I can FOIL it. So 2/3 m minus n times itself. All right, so I do my first. 2/3 times 2/3. So when you multiply fractions, you just multiply straight across. So think of it as 2 times 2, 4, and then on the bottom, 3 times 3, 9. M times m squared. Then outside. So 2/3 times, remember these are negative ones in front of these n's. So 2/3 times negative 1 gives you a negative 2/3 mn. Inside, 2/3 times negative 1, so another negative 2/3 mn. And then last, negative times negative gives me a positive, 1 times 1 is 1, n squared. You don't have to have that 1 if you don't want it. Last step, let's combine like terms. So I have 4/9 m squared. Negative 2/3 and negative 2/3. Remember, when you're adding and subtracting fractions, you keep the denominator. And actually, since they're both negative, we're going to add it and keep it negative. So I'll have a minus sign. We'll keep that denominator and just add our numerators. 2 and 2 gives me 4. So minus 4/3 mn plus n squared. And again, you can put the 1 in front of the n squared if you like, or you can delete it as I did. Okay. Pause, try A and C, check yourself by the solution key. All right, let's flip it over then to our last page. You'll notice that we can't, I just made a little note here, you can't apply exponents over addition or subtraction, okay? Whenever you see an addition or subtraction sign, you have to actually multiply out the expression, okay? You can't just, so I've got an example down below just so you can see what I'm talking about here. So in example 5, it says to multiply each expression and simplify. So in letter A, when it says 7x squared, then really what that means is 7x times 7x. So you can write it out like that, or you can think about how we did in the previous, or a couple of sections ago, where we just said, okay, well, everything in this parenthesis gets squared. So 7 squared is 49, and x raised to the second power, power to a power, you multiply, so 1 times 2, 2, 49x squared. But once you have an addition sign, this is what I meant here, is I can't say 7 squared and x squared. That is not 49 plus x squared. It's a common mistake, but once you see an addition or subtraction sign, that little 2 up top means then I've got to write this expression twice and go back to foiling. Because like I said, this is your final answer here is not going to be 49 plus x squared. It's going to have both of those terms in it, but you're going to be missing your middle term if you don't FOIL it, okay? So as I FOIL here, I do my first. So 7 times 7, 49. Outside, 7 times x. Inside, 7 times x. Last, x times x. And then I usually write my final answer in descending order, so I'll have x squared plus 14x plus 49. Final answer. So once you have an addition or subtraction sign being raised to a power, then that means that you've got to write that expression however many times, whatever your power is, and then actually go through and multiply. But if you just have one term, then you can raise everything in that term to that power. All right, let's look at another variation of multiplying sums and differences with binomials. And so I'll just come on down. And what you'll notice here is that when the first and last terms are the same in a binomial, and the only thing that's different about them are their signs, then you're going to notice that your outside and inside terms are always going to cancel out, okay? So I'm going to come down and do letter C here. And I'll do A and C with you just so you could get a good representation here. So find each product. It's a 2 term times another 2 term, so you're just foiling. So when I FOIL here, and you'll notice that the first terms are both A's, the last terms are both 6's, the only difference is a positive and a negative, okay? So as we FOIL that out, you're going to see how those inside terms will cancel out in this case. So when I FOIL, so A times A squared. Outside, A times negative 6, minus 6a. Inside, positive 6 times a. And then last, positive 6 times negative 6. This time I've got a negative 6a and a positive 6a. They cancel out for a final answer then of a squared minus 36. As you get more comfortable with these, you might be able to do a little bit of that in your head. Okay, it's totally up to you. I'll show that work though. All right, moving on over to letter C. I'm going to FOIL here as well. So, but again, you'll notice the first term and the last terms are both the same. The only difference is a positive and a negative. So when I FOIL, so 3p to the fifth times 3p to the fifth. So 3 times 3, 9. When you multiply, add those exponents. Outside, minus 21p to the fifth. Inside, positive 21p to the fifth. And last, 7 times negative 7, minus 49. And now from here, you notice again those middle terms, one's negative, one's positive, so they cancel out. Final answer then, 9p to the 10th minus 49. So really the only difference between this one and our previous problems is that this one has the same first and last and different signs. The other ones that we just got finished doing had the same signs on both, so the middle term was not canceling out. All right, so let's talk about multiplying a polynomial by more than one term. There's several different ways that you can do problems like example 7. You can go through and multiply everything times 3a and then multiply everything times negative 4 and then combine your like terms. I like to use I like to go back and utilize the technique of old school long multiplication, because by doing it that way, your like terms will end up lined up underneath one another in most cases, and it just makes the combining like terms that much easier. So here's what I mean by that. I always put the bigger polynomial up top. So the 5a squared plus 2a minus 8 has 3 terms. So I'm going to put that one up top. And then I'll put the 3a minus 4 down here on the bottom. You're going to notice I'm going to end up multiplying everything times negative 4 and then everything times 3a. It's just that the way that it's going to structure it, it's going to structure it so that my like terms, like I said before, will be underneath one another. All right, so let's run through that. So I'm going to take everything first and multiply it times negative 4. So negative 4 times negative 8, positive 32. Negative 4 times 2a, minus 8a. Negative 4 times 5a squared, negative 20a squared. All right, so now we're going to go through and multiply 3a times everything. 3a times negative 8, so 3 times negative 8, negative 24a. So I'd put it underneath its like term. 3a times 2a, 6a squared, and it was positive. 3a times 5a squared, 3 times 5, 15, a times a squared, a cubed. So now I've gone through and I multiplied negative 4 times everything. I multiplied 3a times everything. Last step, just add them, combine like terms. So you have your 15a cubed, negative 20 plus 6, so a minus 14a squared, minus 32a plus 32. And that'd be our final answer. This right here. Okay, I encourage you to try letter B. You might want to, on the solution key, I showed this exact same setup that I used here. But again, if you would just prefer to multiply everything times x and multiply everything times negative 6 and have it all written horizontally and then combine like terms, that's perfectly legal. Okay. All right, so I'm going to flip it on over then to our last page. And on this page, you're just looking at an extension of everything that we've talked about here in multiplying polynomials. In example 8, I'm going to do letter A with you, and in example 9, I'm going to do letter B with you, and let you try the other two on your own. In example 8, you'll see that you've got a monomial times 2 binomials back here. So what I would recommend that we do is let's FOIL first, and then we'll multiply that 3x through, okay? Got a couple of options, but that would be what I would recommend to do us doing. So I'm going to bring down that 3x, and then I'm going to FOIL with the back end. So first, 4x times 2x, 8x squared. Outside, 4x times negative 3, minus 12x. Inside, 5 times 2. Last, 5 times negative 3. All right, I'm going to combine like terms. So I have 8x squared minus 2x minus 15. Last step then is I'm going to take that negative 3x and distribute it through. So 3x times 8x squared, 3 times 8, 24x cubed. So you multiply, add those exponents. 3x times negative 2, so 3 times negative 2 minus 6x squared. 3x times negative 15, and negative 45x. Final answer. Okay, I would approach letter B the exact same way. FOIL first, and then I'll multiply by negative 6m. All right, now come on down to example 9 and look at letter B. So you'll notice here that, you've got a binomial here raised to the second power. So remember what we were talking about earlier. Anytime you have an addition or subtraction sign in there, then that means that I'm going to have to write this x minus 7 twice so I can FOIL it. Likewise with the x plus 9. So x plus 9, I need to write it twice so I can FOIL it. Okay. So I'm going to keep these in parentheses, so when I FOIL here, so I've got my first, so x times x, outside, inside, last. All right, so that's the first one, got it in parentheses. Now let's do the next one. FOIL back here, so first, x times x, outside, inside, last. All right, let's clean up both of those parentheses. So I've got x squared minus 14x plus 49, x squared plus 18x plus 81. All right, so now remember, because you've got that minus sign, that's a negative 1 that's going to be distributed into the parenthesis behind it. So I'm going to bring down the first one. Now take negative 1 and distribute it through. So negative 1 times x squared, negative 1 times 18, so minus 18x, negative 1 times 81, minus 81. Now combine like terms. What happens to those x squareds? Hopefully you agree. One's positive, one's negative, so they're going to cancel out on us. So I'll note that for us. Negative 14 and negative 18 combine to give me negative 32x. 49 minus 81 combines to give me a negative 32. Final answer. Okay. All right, that finishes up this section. Thanks a lot. Bye.